What you saw now might look interesting, and even it looks easy, and you want to try. But the truth is, it isn't.
For a sub 5 solve, you have to solve the cross, which is solving these 4 pieces in 3/5 of a second.
And there's more. You have to solve the F2L, which is the first two layers, in 1.8 to 2.5 seconds. And OLL, orientation of the last layer, should be solved in 1 second, and PLL, permutation of the last layer, should also be solved in 1 second. The average TPS, turns per second, of a sub 5 cuber will be 9.5 to 11.5 turns per second.
Their brain ends up recognizing well over 1,000 patterns and variations automatically.
They can perform on-the-spot solution memorization, seeing a random scramble, planning parts of a solve in seconds, and recalling those moves flawlessly while turning out an incredible speed. The cross is the first step of CFOB. During a 15-second inspection, you should be able to find a solution for all 4 cross edges before starting the timer. A good cross is usually 5 to 8 moves and should be executed in under 1 second. The goal is to start solving without having to think about the cross at all. First pair prediction. While planning the cross, you also track pieces that will form the first F12 pair. This means that as soon as the cross is finished, you already know exactly which pair you will solve next. Tab solvers often predict the first 2 cross. X cross. An X cross is when you solve the entire cross and one F12 pair at the same time. Instead of finishing the cross and then starting F12, you integrate a pair into the cross solution, saving moves and time. Double X cross. And double X cross is an extension where you solve the cross and 2 F12 pairs simultaneously. This is rare but very powerful when available. F12, first 2 layers. F12 involves pairing a corner and edge piece together and inserting them into the slot. Since F12 takes most of the solve, this is where the largest improvements come from. Look ahead. Look ahead means searching for the next pair where solve the current one. The goal is to never stop turning. Many cubers know the algorithms but pause between pairs. Sub-5 solvers avoid this process. Pair prediction. This is a more advanced form of prediction. Before finishing one pair, you already know how you will for the next pair. Multi-slotting. Multi-slotting means using the moves of your current pair to help another pair. For example, while inserting one pair, you may accidentally create or improve a second pair. Skilled solvers do this intentionally. Pseudo-slotting. Pseudo-slotting is when you temporarily place pieces into wrong slots or use unusual pairings to make multiple pairs easier to solve later. It often results in fewer moves overall. Keyhole. A keyhole occurs when one F2 slot is empty. The empty slot can be used as a workspace to move pieces around more efficiently before inserting them into their correct positions. Edge control. Edge control means intentionally orienting last layer edges during F12 so that the OLL case becomes easier. Instead of accepting a random OLL, you influence which OLL appears. Window variation. Window variation is a set of algorithms used when solving the last F12 pair. It inserts the pair and orients all the last layer corners at the same time, reducing the work needed later. Summer variation. Summer variation is related to window variation, but focuses on different last layer situations. It is less commonly used. VLS. VLS solves the final F12 pair by simultaneously orienting the entire last layer. If performed correctly, you can skip the OLL completely and go straight to BLL. OLL, orientation of the last layer. OLL makes all the obstacles face upward. Full LL contains 57 cases. PLL, permutation of the last layer. PLL moves the already oriented last layer pieces to their correct locations. Full PLL contains 21 cases. Two-sided PLL recognition. Similar to OLL recognition, this allows instant identification of PLL cases by observing multiple sides instead of rotating the cube. AUF, adjust U face. AUF stands for adjust U face. Sometimes of OL or PL, you only need a U prime or a U to turn to finish the solve. Tab solvers often predict this before they finish the algorithm. Fingertips. Fingertips are optimized ways to perform moves using fingers instead of whole hand re-grip. Efficient fingertips make algorithm much faster and smoother. Re-grip. A re-grip is changing your hand position during solve. Re-grips takes time, so tab solvers try to avoid unnecessary ones. Turning accuracy. Fast turning is useless if you constantly lock up. Turning accuracy means performing moves cleanly and precisely while maintaining speed. Inspection efficiency. The best solvers use their inspection time effectively. By the time the timer starts, they may already know the entire cross, the first F2 pair, sometimes the second pair, and possible X-cross opportunities. Rotationless solving. This means solving F12 with a very few cube rotations. Fewer rotations generally lead to better look ahead and faster solves. Neutrality. Color neutrality means being able to start on any cross color rather than only white or only yellow. This gives access to easier crosses more often. Before I start this journey to become a sub 5 speed cuber, I wanted to know exactly where I stand. So I made a checklist of every skill a sub 5 cuber needs. I expected to be missing a few things. I wasn't. After going through the list, I realized I'm nowhere near sub 5. Sure, I know full OLL, full PLL, and intuitive F12. I have a basic understanding of look ahead and I can span simple crosses. But that's only the beginning. I still need to master X crosses, advanced F12 techniques, fast recognition, finger tricks, efficient inspection, fluid turning, and so much more. In other words, I have a lot to learn. And that's exactly why I'm making this series. Every video, I'll be laying on of the skills, training it until I truly understand it, and documenting the entire journey. This is day